In this video, we are going to work through the 7 steps that it takes to solve a system of linear equations with 3 variables. Now, the first step you want to do is you want to write the equations in standard form. So we want, it to have usually it's x, y, and z. So our x term plus our y term plus our z term equals the number. You want them all to be in that same form so that we can line them up perfectly. And if there are any coefficients that are fractions, you can clear them if you multiply through by the common denominator. The second step, we are going to eliminate the same variable from 2 equations. We'll decide which variable we're going to eliminate by looking at the coefficients, looking how they're related, and then we're going to work with pairs of equations to eliminate that chosen variable. Now you're going to have to repeat it twice. Whatever 2 equations you start with the first time, the third equation has to be used with any of the other 2. So you have to use a different pair of equations. We'll solve this new system that will have 2 variables, and then we'll use those 2 variables to find the third. Now, the solution will be an ordered triple. We're used to that XY ordered pair. This will be an XYZ, so it'll be an ordered triple. And then we can check these in all of the 3 original equations to tell us whether or not it is correct. So let's break it down with a problem. So we'll go step by step. So we have this system here. You'll notice that the first step tells us to write it in standard form, and if any of the coefficients or fractions, we're going to clear them. Well, you'll notice we have the x's, then the y's, plus the z's equals a number. So we have it in standard form. There are no fractional coefficients. So step 1 is done. So we can move on then to step 2. Now, step 2 says to eliminate the same variable from 2 equations. Decide which variable you will eliminate and work with a pair of equations to eliminate the chosen variable. Now, I like in this particular one, we can use y's are good. We got this simple x here, y's. We have these y's matching. But I think the simplest variables in this particular system are the z's. So let's try to eliminate the z's. So I'm going to work with my first 2 equations, and you'll notice they're already perfect opposites. That's great. So we don't have to do anything to make those z's be eliminated. And we do that by adding the 2 equations together. So that's why that standard form is so helpful. Okay, so if you add up the x's, we get 3x. If you add up the y's, in this case, those eliminated themselves too, which is great. That doesn't always happen. Then our z's are eliminated. And then at the end, we get -3 plus 6 is 3. So we get a very simple equation, 3x equals 3, so x is equal to 1. Now, you have to repeat step 2, eliminating z again. So if we multiply that bottom equation through by -1, we will change that z term into a positive z. They will be opposites. They'll be ready to go. So let's go ahead and leave our top equation alone, our bottom equation here. Let's multiply through by -1. So when we do that, we get -3x plus 2y plus z equals -3. Now that these 2 terms that we're trying to eliminate are opposites, go ahead and add those 2 equations together. When we add those 2 equations together, look at our x's, we get -x. Our y's, we get 5y, and then bring down your equals. And then we get -6. And now we can move on to step 4. So step 4, we're going to use those 2 equations to solve the system with x and y. Now, the great thing about this particular step is when I did that first elimination, I found that x was 1. So I can just immediately plug in 1 to that spot. So by substitution, if I plug 1 into that spot, I get -1 plus 5y equals -6. Let's add 1 to both sides of our equation. So that would move that over if we added 1. So -6 plus 1 is -5. We still have to divide by this coefficient of 5, giving us a y value of -1. So now we have x is 1 and y is -1. That brings us to step 5. Now, step 5 says to use the values of the two variables found to find the third variable. Now, we already know that x is 1 and y is -1, so now we need z. Now, I think this middle equation here is a good option, but any of the equations above have a z in it, so we just have to use substitution. I decided, again, I pulled this middle equation out. I'm going to substitute a value of 1 for my x and -1 for my y. You've seen I've done this here. Now let's follow order of operations here. These two negatives are going to make a positive, so we're going to get 1 plus 3 plus z equals 6. Add those together, get 4 plus z equals 6. Subtract 4 from both sides, so z is 2. So now that we have our three variables, that moves us to step 6. We're going to write that as an ordered triple. Now remember, x is 1, y is -1, z is 2. If they use different variables, just go in alphabetical order is common. And so our x, y, z, our ordered triple is 1, -1, 2. Now that leads us to our final step, check your work. So we've got that ordered triple. To check our work, that ordered triple has to be able to be substituted into all three equations and get the values we see here. So let's start with our first one. If I plug in 1 for my x, -1 for my y, and 2 for my z, I get a value of -3, which is what I wanted. Now if I plug into the next equation, I should get 6, which is exactly what happens. I get 1 plus 3 plus 2, which is 6. And then finally, if I substitute in the last equation, you'll see I get 3 plus 2 minus 2, or 3, which is what I wanted. Because when we plugged it in to all three equations, we got the values you see here, then it is a correct solution. So that is how we solve a system of linear equations with three variables. Thank you so much for watching. You have a good day.